So I've been doing a lot of work recently restoring some frequency counters, vintage frequency counters, making YouTube videos on them, producing new documentation for them, and so on. And a lot of them are much faster than the signal generators I have in my laboratory. I have some vintage stuff like old HP stuff, which are very nice, but they just don't go that fast. They're not really into the RF range. And my Siglent DDS is perfectly fine, but it only goes to 25 megahertz. And actually an awful lot of signal generators, unless you spend a lot of money on them, peak out in that same ballpark. So I was trying to find something that wouldn't break the bank, that would give me, well, I was figuring if it wasn't at least 100 megahertz, I wasn't going to bother with it. So on June 9th, 2024, I selected this item, which was available from Amazon. And I should point out that I found some similar things, and maybe things that looked a little better, slightly maybe, on, AliExpress or whatever, and some of those other websites, but I wanted to get the kind of customer support protection that Amazon offers and be able to make the purchase without having to create a new account or any of that nonsense with websites I don't entirely trust. So this one is the one I picked. It's the so-called, well, it doesn't even mention a brand in the title, but here it calls it FeelTech. It's the model FY6900, and then it's available in a 20 megahertz, 30 megahertz, 40 megahertz, 50 megahertz, 60 megahertz, 80 megahertz, and 100 megahertz model. It's a digitally generated function generator, and it also supports arbitrary waveform generation. It's actually a dual channel signal generator, so it's like having two signal generators in the same case. And it also includes a frequency counter, which a lot of signal generators do have these days. You can select, at least on this Amazon page, the I think most of the models. It shows the 80 megahertz one up here, but then down here you can't select the 80 megahertz model. If you just want to spend $123, you can get the 20 megahertz one. 30 gets you, or costs you $133. 40 goes up to $164. 50 megahertz goes to $177. 60 megahertz goes to $194. Then it jumps to the 100 megahertz at $256. For all I know, it's the same exact model with some firmware tweak or something. Don't know. I googled around to see if there was any information on that, and I really found practically no mention of this model, so I decided that that wasn't too much for a 100 megahertz function generator, and I popped for it. Like I said, I ordered it on June 9th, 2024, and I received it, I think it was the 19th or something like that, not too long after I ordered it. And it did have to come from China. I was getting information about it as shipped from China, that kind of stuff, so not stocked in the US apparently. And I think it came through on one of those bulk shipments where they just put a whole bunch of stuff in a container, and then it goes to someplace in the US where they divvy it up and then ship it out locally. In my case, through the US Postal Service. And actually, I'm in the Chicago area, and the shipping address was in Franklin Park, Illinois, which is a Chicago suburb or Chicago area town. Anyway, I decided to make what's hopefully going to be a very short video just pointing out a few things about this, showing what it's like, in case anybody else is interested in this product. The signal generator does not come with a manual in the box. At least mine didn't, so probably none of them do. It has a quality certificate business card type of thing in there. That was the only piece of paper in the box. Mostly in Chinese. There are a couple of websites. It says WED instead of web. www.feeltech.net, FeelElec.com. I tried both of those. The second one didn't even work. The first one was all in Chinese. No option for English that I could find. I wouldn't recommend clicking on anything there. I did find this through a Google search, EN, which I presume stands for English, /FeelTech.net. So it is the same as the first one here, but you got to put the /EN in front, or EN/ in front of it. And that was all in English. It does cover all the different models of this signal generator, and it's decent enough. It's not bad Chinglish, it's decent enough English to be able to read it, and it seems fairly thorough. So that's what I've been using in my explorations of this so far. I haven't printed it out yet, but I do have it downloaded. After I downloaded it to my secure blockaded section behind my firewall and checked it out several different ways, it looked like it was a secure enough document. Nothing seemed to have come in with it. Here's a page from the manual that I printed out. Here's a list of the waveforms that the FY6900 can output. Sine wave, square wave, rectangle, triangle / ramp, rising sawtooth, falling sawtooth, Lorenz pulse, multitone, noise, doesn't say what kind there, electrocardiogram, really? I wonder how that works. Trapezoidal pulse, sync pulse, narrow pulse, Gauss white noise, step triangle, positive step, inverse step, positive exponent, inverse exponent, positive falling exponent, inverse falling exponent, positive logarithm, inverse logarithm, positive falling logarithm, inverse falling logarithm, linear FM, AM, FM, positive half wave, negative half wave, positive half wave rectification, negative half wave rectification, and the user-defined waveform, which would be the arbitrary waveform. And there's a table here on which parameters you can change for those. And pretty much everything can work on everything except duty cycle. Doesn't apply to everything. You cannot select the duty cycle of a sine wave, obviously, or a square wave. That's always going to be 50%. Triangle wave, you cannot. Sawtooth, ramp, you cannot. Arbitrary waveform doesn't make sense. And they say you can download the PC software from FeelElec.com, but again, that's in Chinese. Presumably if you put the EN/ in front of it. I didn't look on there, but I think there was the downloadable software. I think I did spot that when I was looking for the manual. I should note that the manual online, the downloadable manual, and indeed every place I found information on this, stops with the 60 megahertz model. It does not include the 80 megahertz or the 100 megahertz model. Although the dates on this product, including the manual, are like 2019, so I think this series has been out for a number of years. Perhaps the 100 megahertz model is newer. That I don't know. While this is a 100 megahertz signal generator, that only pertains to the lowest harmonic waveform, such as the sine wave. Indeed, the manual says if it isn't, and this is pertaining to the 60 megahertz model, which is the highest the manual even recognizes. On the 60 megahertz model, the sine wave can go up to 60 megahertz. Square waves can go up to 25 megahertz, and I presume that's still true for this higher speed model. The ramp and triangle waves are only 10 megahertz. Pulse is the same. Arbitrary waveforms the same. And noise, you can generate white noise, etc. Those are all limited to 10 megahertz. Although I'm not sure how you can assign a frequency to white noise, but that's what they say. The output impedance of the two BNC jacks is 50 ohms, as you would expect on a function generator. The frequency counter, they say it's an absolute maximum of 5 volts and a preferred maximum of 1.5 volts. So if you hooked it up to a TTL level signal, you'd be right at the maximum. That's a little disappointing. I would think that any frequency counter should be able to handle a 5 volt signal, and without feeling like you're about to burn it out doing so. Having said that, I can think of a lot of other frequency counters I've looked at that have kind of like a 2 volt preferred maximum input signal. And while a lot of the documentation says FeelTech on it, here the label is FeelElec, and the model number again is FY6900. I don't know what the FE is for. Maybe that's just the logo of FeelElec. Alright, here's the unit. It's pretty small. Not much bigger than my hand. It is not in the category of sort of industry standard stackable equipment that most serious stuff comes in. And that has some downsides. Number one, it makes it look toy-like. And number two, this is really not stackable. The design would not stack. If you put something else like this on top of it, there'd be no place for it to lock in, and it would just slide all over. It's supported only by these things on the corners, which normally are rubbery material when they have it. And here it's just made to look like that, so it's a little bit, yeah. On the other hand, these do protect the buttons and the rear connectors, but they do not protect the BNC connectors on the front, which ideally they would, but lots of other stuff I have that has the rubber bumpers, they do not extend out to protect delicate knobs and BNC connectors, so not an unusual situation there. The case is supposed to be made of ABS plastic, which is like the same thing Lego bricks are made out of, and car bumpers and so on, so it's probably reasonably robust against damage. Although the way the circuit boards and things are mounted inside here, there's nothing about that makes it look like those would survive much of a drop. If you drop this, the case might survive, but you'd probably have some G-force related damage on the inside. This unit measures roughly 8 inches wide, including the hubs of the handle. So about 8 inches, or about 20 centimeters. And tall, it's about 3 inches or 7.5 centimeters. Front to rear, it's about 7.5 inches and 90 or 19 centimeters. The handle does fit into the empty space underneath the case, so at least if you don't want the handle, you can fold it up underneath and it won't rock on that. However, it only has one detent for use as a kickstand or bail, and that has what seems to me to be a little bit of a shallow angle. It could stand to be a little more like that, so you might still need to block it up on something. The next detent is carrying handle position, and then there is no more detent except flat back on the top, which if you were to stack something or try to stack something on this, it would rock on the handle because it, unlike its position on the bottom, it's not flat with the top perimeter of the case. So not bad if it's by itself and you don't want it underneath, but otherwise not a very useful position. When I was talking about the dimensions, I didn't mention the weight. The weight is only a little bit more than a pound, not counting cables, power cords, and such. Just the basic unit is only a little bit more than a pound, so feather weight, really. It feels like it weighs like a sandwich or something, or a paperback book. You know, it's very lightweight, and that's problematic when you're trying to push buttons on it. And even the power cord feels like it's going to drag this right off the bench. So you're up here and you're trying to push a button and it's just moving around. You know, it won't stay put. And if you fold up the handle, it's even worse. It seems to slide around even more readily. So that's pretty bad. I would always say the mark of equipment is that you should be able to push the button on the front without it moving around. And indeed, that's why a lot of this equipment is as big as it is. You know, if you look at this B&K Precision multimeter, it doesn't need that big honking case for multimeter function. I think if you open this up, you'd find there's a little power supply in the back, and then a circuit board on the front, and probably not much more than that. But you need that for A, stackability, and B, just so there's enough mass that the thing is going to stay put on a workbench when you're trying to use it. The same thing for any of these others. It's just something that you do to make the equipment more practical. So in that way, this is a fail. You do need to hold it with one hand while you're pushing buttons. It comes with, at least if you buy it in the US, it comes with a US style plug and an IEC power connector on the other end, but it's a very short cable. It's only about 3 feet long. So not bad if you have a bench with a long outlet strip, but if you're running things down to the floor, for example, for outlet strips on the floor instead of on the bench, this will be too short and you'll need to buy another cable. It comes with a pair of BNC to BNC cables, which is nice. They are not very flexible, they're kind of springy, so cheap plastic on them, and not what you'd really like to have on test leads. And that may be from the plastic and maybe from the insulation, but considering how thin these leads are, you would think they'd be more flexible. And these are only 20 inches long, so very short. Maybe long enough in some situations, but certainly shorter than normal test leads that you're liable to buy commercially. There is a USB-A to USB-B cable, and it's about 3 feet long. Again, kind of short, unless you're just connecting it up to a laptop computer that happens to be right next to this on the workbench. And you do need to use the USB for things like, and you have to use their downloadable software if you trust it, for things like setting up the arbitrary waveforms, should you want to use the arbitrary waveform generation capability of this product. You can't do it with the front-end user interface, as some of them allow you to do. So you need this or something like it if you're going to get into the more advanced features. And then finally it comes with a pair of BNC to alligator clip test leads. And these are 3 feet long from the BNC up to the point where the cable splits. And then you have another about 6 inches of discrete wires going to the alligator clips on the ends. This is a more useful thing probably for a lot of applications. Seems to be of reasonable quality. So let's just take a look at the front panel. There's a soft power button. As far as I can tell, that's basically turning on a lot of the electronics, but not all of it. That's because the real power switch is a physical switch back on the IEC power cord connector on the rear panel. So it's always got some power going on, and this is just a soft button turning on the display and some other functions. That's not terrible. A lot of things are like that, although on test equipment I prefer to have a real power button, and really everything I have on my bench has a real power button that really turns the power on and off. Except for my Siglent digital oscilloscope, which has a soft button on the front. There's a 2.5 inch diagonal color LCD, I believe, screen, so 2.5 inches diagonal. There are 5 soft buttons here, or function buttons, which their use depends on what the screen says on its right hand side. Although most of the time the top one's going to be for setting frequency, the next one for setting amplitude, and then things like offset and duty cycle would be the lower buttons. Those are the usual function assignments. Then there's a group that's actually called function buttons. The wave button allows you to select the waveform for the currently selected channel. Mod is for modulation, setting it up for various types of modulation. It can do a sweep function, and that's set up with this button. You can switch to the frequency counter mode, because again this has 2 function generators and a frequency counter in the case. So this gets you into the counter and setup thereof. There's a voltage control input. It's just called VCO on this for labeling on the rear panel and the button, but it really allows voltage adjustment of frequency or amplitude or offset or duty cycle, etc., with a 0 to 5 volt, I believe, signal, DC signal. The signal that's used as the voltage control has a maximum frequency of 500 Hertz. And then system gets you into the system setup, so overall configuration, setting of user preferences, and so on. One of the things I don't like about this is that it came from the factory with the system setup such that both of the outputs were on and set to parameters I thought were ones I would rarely use, but you can go into the system setup and change things like that. For example, you can set it up so when you push the button here to turn it on, these outputs would be off, and then you'd have to push their buttons to turn them on, instead of the way it's default, that they default to the on position or the on status. The OK button is not real clear to me here. That's supposed to be to accept current settings for either channel, but the manual doesn't really mention it that much. It says you can push the knob here, you know, click the knob to do that, but this knob does not click. There's no indication here that anything happens when you push on it. And it's actually a very cheap knob considering how important it is to setting everything. And yeah, it has this little finger thing in there, but it's so shallow and the knob is kind of stiff. You can turn it that way, and indeed it's easier to do that than turning it this way, just because it's hard edged and there's not much to grip onto there. It's not a great knob. A lot of other equipment that has those, it's a much better knob that turns easier, you know, and they may or may not push in. This one pushes in. Again, very easy to turn. This is a little disappointing. If I was to use this as a regular workbench tool, I would want something with a better knob than that. The two cursor buttons pertain to the knob, so you're changing one parameter at a time, usually one digit of a parameter at a time, and you're selecting that with these two buttons, and then changing, and then selecting something else and changing it. There is no keypad, obviously, for direct parameter input. The two channel buttons also light up. If you just tap them, that makes that the primary channel, and primary and secondary here doesn't mean one rules the other one or controls the other one. It just means whichever one is displayed at the moment and what this knob will affect. So if channel 1 is the primary, then this knob and these buttons will affect parameters for that channel. These buttons will pertain to that channel, and the bulk of the display will be about that channel. Then you tap the other button, and then that channel becomes the primary one. Pushing and holding just for about a second is what you do to turn the channel on and off, toggling between on and off. Each channel has its own BNC input. Then the frequency counter has its own BNC input. Has to be less than 20 volts RMS. Going around the rear again, there's a hole for a fan, but there's no fan. And indeed, there's no place on the inside to mount a fan. You know, it's like, it's there to make it look like a more serious piece of equipment. I think it does serve as an air vent, but because they shaped it like a fan without providing any means to mount a fan on the inside, that is just a cosmetic feature. It does say here that the input power can range from 110 to 240 volts, that it requires a maximum of 10 watts. Here's your USB-B connector. I'll get to this in a minute. There are these 4 rear BNC connectors. This one is for inputting various signals depending on how you have it set up on the front. It can be a trigger for the pulse generation function. It can be a trigger for the sweep function. It can do all sorts of things, FSK, ASK, PSK, so it can do a lot of stuff depending on how you have it set up on the front. Then this is the VCO input, which, as I've already mentioned, is a 0 to 5 volt DC signal, and it can control many things about the waveform generation, frequency, amplitude, duty cycle, offset, and so on, all under control of this. I have not yet experimented on how you set it up to decide which channel it affects, but that's apparently in the setup for those more advanced modes. You can synchronize more than one of these together, and you can have one be in charge or in control of the other one. So you can take the sync output and connect it to the sync in of another one and have them operate as if they're additional channels on the same function generator. And then finally the TTL, it has 8 pins. One of them is ground, one of them is 5 volts, one is a serial receive like RS-232, one's a serial transmit, and then the A, B, C, and D. A is a TTL level version of the channel 1 output. B is the same thing but inverted, or 180 degrees out of phase. C is the TTL level version of the channel 2 output, and D is the same as C but inverted. So that might be useful for something. Not that there are any user serviceable parts in this, but you can take it apart without much in the way of tools or special knowledge. I've already done so, and they even publish a document which you can download from the website on how to take it apart. First off, they say just peel off this serial number sticker. I just use an X-Acto knife to cut a bit of a hole while leaving the number there as kind of a flap. And there's a single Phillips head screw which ties the top and bottom case halves together, because the case is in 2 parts that separate along this line. And then the front and rear are identical, and they just pry off. There's 4 pry points, one here, the mirror image of this, and the mirror image of this. So you get a screwdriver or a pry tool onto those, and it pops off pretty easily. Same thing with the front. And once you've got the rear pulled out about 1 inch and the front pulled forward about 1 inch, then you can lift the case halves off. Really, you can lift the top half off because the circuit boards remain screwed onto the bottom half. And indeed, the handle goes with the bottom half. So that stays attached when you lift the top off. I took some photos when I had this apart, and I'll include those as a bit of a slideshow. Alright, let's turn it on real quickly here. Reach around the back, turn the power switch on. You get a firmware thing for a couple of seconds, and you got the screen. It's a pretty legible screen. Decent colors, decent brightness. Pretty easy to read. Whatever parameter is currently selected to be adjusted is highlighted in red. And you can see here that currently channel 1 is selected as the primary. Channel 2, it gives you a more compressed set of parameters and without the graphics. Now if I go over and tap the channel 2 button, now channel 2 is on the top and channel 1 is compressed. So that's how you can select which one you want to make adjustments to. It's also color coded. Channel 2 is blue and channel 1 is yellow. But you can see how here I had it so the outputs both turned on when the unit was turned on here. Let me see if I can go into the system right here, right while we're doing this. Model version language, English buzzer, uplink, sync, save load, sync, configure, maybe configure. You can configure the buzzer on here. I think you can go into Chinese. I don't know how you get out of this actually. Push the English button. That doesn't do anything. No, that just took me straight into the normal screen. not mentioned in the manual is what happens if you push this more button. Here we go, that's where it's at. So you can push this function key to change that on boot. Channel 1 is currently on the on state. I can turn it off. Likewise for there. You can also set back to factory defaults using the third button here. So now, the only way I know to get out of the menu is to push one of the buttons. So let me turn this off. Turn it back on. That didn't work. Going back into the system configuration menu, it still has those selected to off on boot up, so maybe this is not what they mean by booting. So let's turn it off and then really turn it off on the back. Turn it back on. Okay, that did the trick. Now the output's defaulted to the off position. Alright. And I think you're supposed to be able to change things like the frequency that it defaults to. It's currently selected to, these little colons up here are decimal points, or they're more like you'd have a comma to separate every 3 orders of magnitude. The decimal point is here. So it has a lot of numbers to the right of the decimal point. Let's say I want to make it 1 hertz, so I turn the knob to 0 there. Use the cursor button to move to the right and turn the knob to change that to 1. So now it's 1 kilohertz. And I push amplitude, and I want to say it's only going to be 2 volts. Doesn't say peak to peak or what, it just says amplitude. I presume it means peak to peak. Offset 0, blah blah blah, phase 0, duty cycle 50%. Doesn't make sense for a sine wave, but you can, it's there anyway. And now I want to go to channel 2 and do the same thing. Set it for 1 kilohertz and also 2 volts. Okay, so now I'll push the system button and see if I can save that. I'll push the save button. And then I will turn it off. Oops. I think I didn't go far enough. Well, it came back on set to 1 kilohertz and 2 volts, but they've got these S1, S2, S3, S4, S5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it has 20 different things you can save, and apparently it's still in the save mode. So I'm going to push S1, and then I'm going to turn it off. I'm going to turn it off for real on the back. Turn it back on. Okay, it has defaulted to outputs off, a 2 volt, 1 kilohertz signal for both channels. So that did work. And if I were to push the system button again, I could push the load button and presumably recall specifically various settings that I've made in that regard. Alright, I have channel 1 connected up with a BNC cable to one of my frequency counters. which should be in good calibration. And I've got it going into input A. So I'll turn this guy on. 1 kilohertz, 2 volts, peak to peak presumably, sine wave. And it reads out 999.9863 hertz. So in the ballpark, I would have expected it to be tighter than that. I'm assuming this is accurate. I forgot that I do have another resource for measuring frequency, and that's the digital storage scope I have. I so rarely use it, I forgot about it, that it does work as a frequency counter. I'm presuming its accuracy is pretty good. It's saying 999.98.97. So I don't know if that's the scope moving around or if it's the generator. But it's not terribly accurate, apparently. That's a frequency counter and this scope that are both saying the frequency is, you know, certainly within 1 part in 1,000, but you might expect a little better. On the other hand, this is a cheap piece of equipment, so we'll leave it at that. You gets what you pay for. Still, not a bad little unit for the price. Quite a lot of capability in it. Still at a, go back into the meter reading here. It is still saying 2 volts. And putting it on my scope, I'm verifying that it is 2 volts peak to peak. Not RMS or something. Normally you'd expect it to be peak to peak on a frequency or a signal generator, and that's what they're doing. And as I've probably shown but not mentioned, the waveform that you currently have is shown in the pictogram there. Let's try changing the wave shape. So it's a square wave now. The OK button here cycles through the different choices, but so does the knob. So there's a couple of pre-stored arbitrary waveforms in there. Oh, it's just showing me arbitrary waveforms. Chirp, FM, AM. So there's an AM modulated signal, which is exactly what it looks like it's giving me here. How many arbitrary waveforms are there on this? Way more than you might want. I'm up to 52, and they're all just junk now. You could be spinning this knob a long time to get through all those possibilities. I guess I should be looking at the scope here for different things that it's outputting. Sync pulse, trapezoid, ECG. I wonder if that's what they mean by the EKG on the manual. Random noise, multitone, Lorenz, negative half wave, positive half wave, negative full wave, positive full wave, negative falling logarithmic, positive falling logarithmic, negative logarithmic, positive logarithmic, negative falling exponential, positive falling exponential, negative exponent, positive exponent, or exponential, negative stair. It is stair-stepped. Positive stair-stepped. Stair-step triangle wave. Negative ramp. Positive ramp. Triangle wave. DC. Adjustable pulse. It's a very narrow pulse width and you can adjust the pulse width. CMOS. That's currently a 2-volt signal. I don't know why they're calling it CMOS. Trapezoid. Rectangle. Square. And back to sine. So there's all those many waveform types. Let's go on the square wave here and change the duty cycle. And now, let's see, I push duty cycle. It doesn't highlight anything. It's interesting. So I was in square wave trying to change the duty cycle. It wouldn't let me because it's a square wave. Default 50% duty cycle and you can't change it. You go into rectangular wave and then of course that's the one you can change. So I'm going to cursor over to the most significant position and turn the knob, and it does show you relative to a sine wave what your duty cycle is. I'll turn the output back on so I can see it on the scope. So here the duty cycle is agreeing with what the generator says. 70% duty cycle. 73% on the generator. 73% on the counter. When I change the waveform, back to a sine wave, go back to the counter, it's still reporting a 50%, 56.5% duty cycle. I wonder if there's any DC offset on that. I've got it connected back to its own input, and I'm going to go to the counter mode, and because this is a frequency counter, it has 3 different gate lengths: 1 second, 10 seconds, 100 seconds. What if I go to the 10-second mode? Still seems odd. It would say 50%, 56% duty cycle on a sine wave. 5 digits of resolution here. So it would probably be reading 1 kilohertz with all the zeros there, even if it agreed with the B and K up there. So I'm not sure this is the most, high-end laboratory grade accuracy kind of thing, but for the kind of application I have, it's pretty reasonable, I think. Okay, for the promised slideshow of internal views, here's when I first popped the back off. The only thing that's on the back is the combination power switch and IEC power cord socket with discrete wires running to connectors on the power supply circuit board. Notice that the rear panel BNC connectors are not connected to the rear panel in any way. They merely stick through it. Here's a somewhat closer view of the same thing. You can see the plastic post in the middle of the case where the long screw goes through from the bottom to hold the top and bottom case halves together. That's the only thing that holds the two together, except for, of course, the overlapping bezels at the front and the rear. So here's popping the front bezel off. A circuit board is attached to the front bezel, which has all the buttons and so on it. Everything except for the BNC connectors. And the screen, the LCD screen, is actually between the bezel and that circuit board. Here's a closer view where you can see the probably the display driver IC, and then the folded flex circuit board coming through a slot in the circuit board from the LCD module. And here's the other end of the front panel board, mostly with connectors coming from the main circuit board, but you can also see the round piezoelectric beeper there, which has a tag on it that says remove, and they have not removed it. That may be deliberate. They may have decided that it was too loud with it off, and maybe they thought it's better to leave it on for that reason. Don't know. Here's where I've cut the label on the bottom of the case and removed the long screw that holds the top and bottom case halves together. So with the case top removed, you can see the front panel circuit board, the main circuit board, and the small power supply circuit board. And with some, not ribbon cables, but just cables connecting everything together. Here's a better view of the middle of the main circuit board. There's one really large surface mount IC there that probably does most of the work, but I have no idea what kind it is, and I'm not Dave Jones, so I'm not going to look it up. Over at the front of the main board, you can see the 3 BNC connectors off on the right, and there are 3 relays. Those are the red devices. There's room for more relays. I have no idea what they might put there or why they might put more there, unless it's just a different style of relay that they might have provision for. But I think those are there to connect and disconnect the actual outputs from the solid-state circuitry, but that's only a guess. And you can see that there's a big heat sink with something under it, and I'm presuming those are the output driver transistors or ICs or whatever for the 2 signal generator outputs. In this view, you can see the hub for the handle and the key on the axle, and if you tip the handle to a certain position, kind of upwards, because the handle's currently facing straight forwards, so if you start raising it up above the top of the case, you can get it to where that key lines up with the keyway, and then if you spring the sides of the handles apart far enough, it'll come off and you can have the handle detached.